geometry. This is section 9.7. We start to get into equations of circles here. And we've been talking about circles all along, but we've been doing tangent lines and secant lines, and now we're actually talking about the equation itself of a circle. The distance formula is listed here to start with. That should look kind of familiar to you. A lot of you have that memorized already. So x2 minus x1 squared plus y2 minus y1 squared. The equation of a circle actually comes from this distance formula. So instead of using distance, though, they refer to it as the radius. So radius is equal to the square root of this. Has stayed the same. The only thing that they have changed inside of here is they've switched this x1 here to h and this y1 to k. Now h and k represent the center of your circle. Okay, so the coordinates for h and k, the center of your circle, go in those places for the formula. And then what they've done from this step to this step, kind of in this little mini proof here, is that they've squared both sides. So they square this to get rid of the radical. And then r will become r squared on this side. So r squared is equal to x minus h squared plus y minus k squared. That all comes from the distance formula. So this box right here is a key concept. There is no theorems for this section, so you won't need your theorem sheet here. But this just kind of shows you that x minus h squared plus y minus k squared equals r squared, and h and k are the center of the circle. So let's go down here and we'll practice writing what one of these looks like. Okay. In example 1, we have our center is 1 and our center is at 1, negative 8, and our radius is 7. Okay. Let me scroll up just a little bit more. X minus h, y minus k, and r squared. H and k is the center of the circle. So that means h here is 1 and k here is negative 8. The radius is, plug stuff into my equation here. I've got x minus h, and h is 1, squared, plus y minus a negative 8 squared equals 7 squared. Okay, I'm just plugging things in up here. X stays as h, x stays as x, y stays as y, and then you just plug numbers in for h and k and r. So I've plugged that in here, and then I'm going to simplify this just a little bit. So this x minus 1 squared, we just leave it like that. But y minus a negative 8 can become y plus 8 squared equals 7 squared is 49. So I'll finish out my equation and make it look like that, and then that is what a circle equation looks like. All right. The circle graph at the right, they want us to write an equation for that one. So the center, my hk, is at 0, 4. So h is 0, k is 4. And then the only other piece of information that we need is r, okay, the radius. So if I look at where the center is and I pick a point on the outside of my circle, this is the easiest radius to choose because I can count over that there's 3 units there. So the radius is 3. Something that I probably wouldn't want to do to measure the radius is do like a line this direction. I have no idea how long that segment is because it's kind of going diagonally through boxes. Okay, so kind of either draw it horizontally or draw your radius vertically, and you can count those boxes and see exactly how much that is. So h is 0, k is 4, and the radius is 3. I'm going to plug this into my equation. X minus h is 0, plus y minus k, and k is 4, equals the radius squared. Okay. Now I'm going to simplify this a little bit. X minus 0 doesn't really do anything. That 0 can just kind of go away, so that we'll just leave it as x squared. Okay. Y minus 4 squared, we leave it as y minus 4. And 3 squared is 9. So this is kind of the proper way to write the equation of the circle, and we just leave it looking like that. Okay. Now example 2, it kind of bridges off of that. So they give us that the center is here, but then they said it passes through a point negative 6, 7. Okay. So that means this center right here is at negative 2, 4, negative 2, comma 4, and negative 6, comma 7. Let's say this point right here, negative 6, comma 7. Looks something like that, all right? So if the center is at negative 2, 4, I know that that is h and that is k. But the only thing I don't know is the radius here. I don't know how long that is from there to there, okay? But what I can do is I can use the distance formula to figure out what that radius is. So distance formula, from the top, you can either look up at the top or you can look here. x2 minus x1 squared plus y2 minus y1 squared. Okay, that's my distance formula. So I'm going to start with my second x-coordinate. I'm going to use like negative 6 as my second x-coordinate. Right? So I've got square root negative 6 minus negative 2 is my first x-coordinate. Plus my second y will be 7 minus my first y is 4. Okay, so writing that all in there looks like that. Okay. Negative 6 minus a negative 2 will be negative 6 plus 2. Negative 6 plus 2 is negative 4, and then I'm going to square that here in just a second. 7 minus 4 is 3. And I'm going to square that. So negative 4 squared is 16. 3 squared is 9. I'm going to add those together. That is 25. So my radius is 5. My radius is 5. So r equals 5. And then the only other thing that I have to do is just write my formula. So I write it out as x minus h, and h is negative 2, squared plus y minus k, and k is 4, equals the radius squared. Okay. This double negative becomes a positive, so I have x plus 2 squared plus y minus 4 squared equals 25. And that's what the equation of my circle looks like. Now I think here eventually, maybe on the back side, they're going to give us the equation of a circle and have us draw what that looks like. So if you kind of look through here and see, this x is attached to a positive 2 and this y is attached to a negative 4. When you write out the center of the circle, it's the opposite sign of what you have to start with. So if this is positive 2, that means your center is actually at negative 2, comma, this is negative 4, so it will be a positive 4. Negative 2, 4. And then to figure out the radius, you actually take the square root of that number. So the radius is 5. That matches up with what I had to start with, so we're good to go. All right. Part B, they're having us do the same thing, and they give us a picture of what it looks like. So I know that my h and k are 3 and negative 2, but I do not know my radius. Okay, I don't know that radius there, so I need to do the distance formula again. All right. So the square root of, set this up. My second x-coordinate, I'm going to list as 5. My first x-coordinate is 3. My second y-coordinate is 1. My first y-coordinate is negative 2, so minus a negative 2. All right? If I'm going too fast throughout any of this, feel free to pause. All right? 5 minus 3 is 2, so I'm going to do 2 squared. 1, this will become plus. 1 plus 2 is 3, so that becomes 3 squared. 2 squared is 4, and 3 squared is 9, so I end up with the square root of 13. Now, don't calculate that out as a decimal. The square root of 13 doesn't come out equal, or it doesn't come out evenly, so we'll just leave it as the square root of 13 as my r, okay? And then when we plug it into the equation, I have x minus h. Now, h over here was the center, the x-coordinate of the center, so x minus 3 squared plus y minus k was a negative 2 squared equals, and then I have my r squared, the square root of 13 squared. All right, let's write this out a little nicer. X minus 3 I don't do anything with, plus y minus a negative 2 will become y plus 2 squared equals the square root of 13 squared is just 13. So that's why we didn't want to write this as a decimal, is because this 13 will pop out of that square root. Okay? Now, when you write the equation of a circle, make sure that you're not trying to like FOIL this out, x minus 3 squared. Don't try to FOIL that, or don't try to FOIL the y plus 2. The equation of a circle just comes out as just as left as those quantities squared. So don't worry about trying to simplify that at all. Okay. All right. On the back side, this is where they give us. So this is the equation of our circle, and they want us to find the center and the radius. So center and radius. Okay. The center, I look for these two pieces. All right. And from the front side, this part was x minus h and y minus k. So since this number in here is a -4, I'm going to flip the sign. So my center is actually at +4, comma, switch the sign of a +1. It will be -1. So you look at the opposite sign when you're doing that. Kind of like when we're doing transformations and left and right, negative actually means right and positive actually means left. That's kind of what this is doing here. So -4 actually means +4, +1 actually means -1. And then the radius, you look at this 9, you take the square root, and it is 3, right? So when I'm doing the center is 4, -1, that's this point right here. And if my radius is 3, that means if here's the center, I'm going to go 3 units out. 1, 2, 3. I'm going to go 3 units in all directions. 1, 2, 3. 3 units to the left, and 3 units down. And this is what my circle is going to look like. I really, really hope I can draw this nice. Just like that. Okay? That's what your circle is going to look like. Right? Go 3 units to the left, right, up, down, and that will be what your circle looks like. Okay? So that was kind of going back the other direction, starting from the equation and drawing the information from it and drawing the circle. Okay? All right, a couple more. Example 4 is a story problem. The 3 tornado sirens are placed strategically on a circle around town that can be heard by all. Write the equation of the circle on which they are placed if the coordinates of the sirens are. All right, I want you to draw these lines a little bit darker. This is your y-axis, and this is your x-axis. So it's kind of like 1 over from the left and 2 up is where your x and y axis are. So 0, 0 is right here. You can see that little circle there for 0, 0. So -8, 3 is where A is at. -8, 3. B is at -4, 7. And C is at -4, -1. Okay? So we use those 3 points. We draw a circle, which I already have given to you. But we kind of look at where they cross each other, where they're going to form a circle at. Okay? If I look at like BC being the diameter of my circle, AB is going to kind of go the opposite direction. He's going to be a horizontal line, and the center of my circle is actually going to be this point right here, which is -4, +3, I believe. Okay, and the circle is going to go around that -4, 3. So the center I've designated as -4, 3, and then I need to find my radius. So from this point, it's going up 1, 2, 3, 4 units. It should be going 4 units in all directions, all the way around. So the radius is 4, and then I just write the equation of my circle. So x minus h, x minus a -4 squared, plus y minus 3 is the k value, squared, equals 4 squared. Right? X minus a -4 is going to be x plus 4 squared, plus y minus 3 squared equals 16. And this is the equation of that circle. Right? Right? Last thing that I have is talking about where circles are intersecting. And this is going to be a little bit more difficult of a problem, right? X squared plus y squared equals 4. Let's graph what he looks like. Okay, normally we have like x minus something squared and y minus something squared, but there's just x and y in here. So where is the center located at? Right? There's no number inside of here. It's not in parentheses. When it's just written as x squared and y squared, that means your center is at 0, 0. There's no number attached to the x and no number attached to the y, so we assume that it's 0. Your center is going to be there, all right? And then to find the radius, I look at that 4. The square root of 4 is 2, so I'm going to go 2 units in all directions. 2 to the right, 2 up, 2 to the left, 2 down. So my circle looks something like this. Okay? That's what this equation looks like. Now, I want to see where this circle is going to intersect the line y equals x. Okay? y equals x is a linear function. Linear functions look like straight lines. Most linear functions take the form of y equals mx plus b. Okay, and to graph that, I always start at the b value. Okay, well this one doesn't have a b value. It's y equals x, so it's kind of like y equals x plus 0. I'm starting here at 0, that's where the b is, okay? And then the m tells me where I go. So m is up 1 over 1, since there's no number in front of the x, we assume it's 1. So from here I go up 1 over 1, up 1 over 1, up 1 over 1. I could also go down 1 to the left 1, down 1 to the left 1. And my equation y equals x looks something like this, okay? Now I want to know where these 2 points are going to intersect each other. This one right there and that one right there. Okay. Now, algebraically, this is actually pretty easy. Y equals x and x squared plus y squared equals 4. X squared plus y squared equals 4. I'm going to write this since I kind of made a mess of it up above. Those are my 2 equations, and I'm trying to figure out where they intersect. Okay. Back in Algebra 2 and Algebra 1, we did what's something that's called like substitution and elimination. In this case, I'm going to use substitution because I know y is equal to x. So if y is equal to x, I can take x and I can shove him in where y is up in the first equation. And it's going to kind of look like this. X squared plus x is taking the place of y squared. So it's x squared plus x squared equals 4. Okay? And then when I add those x squareds together, it's 2x squared equals 4. If I divide by 2, x squared is going to be 2. And to figure out what x is, I take the square root. Okay. Now the square root of x squared is x, but the square root of 2 is actually positive and negative square root of 2. And positive and negative square root of 2, square root of 2 is 1.41, I believe. Let me check. Square root of 2. 1.41, yes. Okay. So my x-coordinates is intersecting at a positive 1.41 and a negative 1.41. Okay, that's why I have two points of intersection here, right? Now, from my original equation, like y equals x up here, I know that if I plug 1.41 in for x, the y-coordinate is just going to be exactly the same value as that. So if I plug 1.41 in here, this is the coordinate point 1.41 comma 1.41 also. The x-coordinate is the same as the y-coordinate. Right? Now, if my x-coordinate is negative 1.41, I plug that in up here, the y-coordinate is just exactly the same as that. So negative 1.41 and negative 1.41. That is this point right here where they intersect. So algebraically, I just have 2 points. I use substitution to plug one equation inside of the other to get those points. If that was confusing, you can rewind, or I can help you with it when the next time I see you. But yeah, this is kind of a tricky problem. Kind of flowed pretty nicely though. We do end up with some decimals at the end, but that's it.